students, welcome to PG department of LJ University. This is a lecture series of subject Applied Mathematics for the first semester student in Computer Engineering branch. Here I, Dharmi Patel, presenting a lecture on the topic partial derivative and chain rule from unit number 3, multivariate calculator. Here we will start the topic with concept of derivative and its properties. The chain rule is same as the single variable derivative chain rule, and what is the partial derivative we will understand in this concept. Partial derivative is nothing but it is a derivative for the multivariable function like function of xy, z, function of x and y variable. That means if we differentiate our function with respect to any one variable, at that time we keep another variable as a constant and we are differentiating with respect to single variable, but it is a not total derivative of the function, it is a partially derivative of that function with respect to particular variable. Now we will start the partial derivative. Here let u equal to f of xy be a function of two variable and u depends on two independent variable x and y, then partial derivative of del u by del x denoted as fx or ux, it is a partial derivative of u with respect to x. At that time we keep y as a constant. And del u by del y is fy, it is also denoted as uy, and it is a derivative of u with respect to y. Keep x is a constant. So that is the first order partial derivatives of our function of two variable x and y. Here if we change x, then there is a change in u, and that is measured with partial derivative del u by del x. It is also denoted as f suffix x. And similarly, if we change the y, at that time the change of u with respect to y, when we change the y and the change of u according to y is called partial derivative of u with respect to y. It is denoted as del u by del y. Also it is denoted as f suffix y or u suffix y. So that type of notations remember for further derivatives. Now we will start the second order partial derivatives. So if we first differentiate f with respect to x or y, then we have a first order partial derivative are ready. And now we have a multivariable functions. Ux is also a function of x and y. Uy may be a function of x and y. Now again we are applying the same concept of partial derivative. That means if we differentiate ux with respect to x, then it's a second order partial derivative of u with respect to x like this. So it is a second order partial derivative concept. And here if we rewrite f of xy, then partial derivative with respect to x and partial derivative of y. Now again we are differentiating with respect to x, that is uxx, uxy. Now we are differentiating y, uy with respect to x, then uyx and uxy. In general, we have a uxy equal to uyx for any continuous function of ux and uy. So that is the concept of second order partial derivative. Let us take the one example for this. Here u equal to f of xy be a function of two variable like x cube y minus xy cube plus 5x raised to 4 plus 4y cube plus e raised to xy. So that is a function of two variable x and y, and u is dependent function on two variables x and y. So now we differentiate u with respect to x, then we have a ux is equal to 3x square y minus y cube plus 20x cube. This is constant 4y cube, so its derivative is 0, and last term derivative is y e raised to xy. Similarly, del u by del y, that is the partial derivative of u with respect to y, is x cube minus 3xy square plus that term is constant, so we are putting it 0, and 12y square is the second last term, and last term derivative is x e raised to xy. So these are our first order partial derivatives. Here we have two terms and they are functions of x and y combinedly. So now again we can find the partial derivatives with respect to x and with respect to y. Now we will differentiate del u by del x again with respect to x, that is our second order partial derivative. So now u x x, that means it is also written as del square u by del x square, that can be written as 6 x y minus third second term is 0, so its derivative is 0, and third term derivative will be 60 x square, and last term derivative is y square e raised to xy, because e raised to xy derivative is e raised to xy and we are differentiating with respect to x, so y is come over outside, so finally last term will be y square e raised to xy. Now we will find the second term. Partial derivative of ux is already ready, and now we are differentiating del u by del x with respect to y now. So first function ux we are differentiating with respect to now y. So at that time x is constant. So now we have a partial derivative u xy equal to del square u by del x del y, because already del x is done. So now we have a partial derivative 3x square minus 3y square, and this term will be constant 20x cube because it's not present, y is not present here, and e raised to xy is as it is, and xy e raised to xy because this is the multiplication rule applicable here. And now in the next term we will find the partial derivative of uy with respect to x, that is u y x, that can be written as del square u by del y del x, and here we have a partial derivative is 3x square minus 3y square plus e raised to xy plus xy e raised to xy. So we can see here uxy and uyx both are equal, because these partial derivatives of first order partial derivatives are continuous. And now we will find the uyy, that means del square u by del y square, that is first term is constant because it contains only x, no term of y, and minus 6xy, and then we have a 24y, and last term will be x square e raised to xy. So these are the second order partial derivatives of our function u of x and y. So now we will see some concept of chain rule for the partial derivative. Here, what is the chain rule? So if one function depends on the other function, and that function is dependent on the other one function, then we can find the derivative with respect to chain rule with respect to that particular variable using the chain rule. The same concept is applicable here, but with the concept of partial derivative. Now we will start the chain rule. U is a function of three variables x, y, and z, and x is depends on three another variables r, s, and t. Y is also depends on r, s, and t, and z is also depends on r, s, t. So del u by del r, del u by del s, and del u by del t are what? So that is calculated from chain rule of concept of single variable. So here del u by del r is equal to del u by del x by del r, and del u by del y by del r, plus del u by del z and del z by del r. So that is the partial derivative of del u by del r. Now del u by del s is similar, del u by del x plus into del x by del s plus del u by del y by del s plus del u by del z and del z by del s. So So that is del u by del s, and now similarly del u by del t can be written like this: del u by del x into del x by del t, del u by del y into del y by del t plus del u by del z into del z by del t. So that is our concept of chain rule. And sometimes variables are more than 3 or 2, or there depends number of variables are changed. Now we will see the concept of this partial derivative with the chain rule. Here u is a log x square plus y square, and x is a function of e raised to s and cos t, y is a function of e raised to s and sin t. So we can say that x and y are a function of s and t, and u is a function of x and y. So here we can find u, we can see that u is a function of x and y, and x and y are a function of s and t. So finally, how we calculate del u by del s? Here we will write the formula first. Del u by del x equal to del u by del x by del s, and del u by del y into del y by del s. Now del u by del x is a derivative of log. Log is 1 upon x square plus y square into 2x. And now del x by del s is coming from x e raised to s cos t, because derivative of e raised to s is as it is. And again we are differentiating del u by del y. So it is 2y upon x square plus y square, and del y by del s is e raised to s sin t. So after taking the e raised to s common, we get finally x cos t and y sin t upon x square plus y square. So that is the final concept of, so that is the simplification of above term. And now we have a e raised to s x equal to e raised to s cos t. So after putting the value of x and y in this term, we get this type of simplification, and finally we rewrite del u by del s is 2. Now we will see the concept of del u by del t. So here del u by del t can be written as del u by del x by del t, and del u by del y by del t. So finally, again we are applying the derivative of del u by del x. Already we did in the del u by del s. So similar concept is here, but now we are differentiating x with respect to t. So it is minus e raised to s sin t, and in the second term del y by del t is e raised to s cos t. So that is the concept of partial derivative with the chain rule. And now after taking the 2e raised to s common, we have this type of term, and in the denominator we have a x square plus y square. After putting the value of x and y in this particular term, we get this type of derivatives. Every terms are cancelled, so partial derivative is del u by del t is 0. So that is our concept of partial derivative.